All right, we are live on air. Welcome to this week's OpenStack Bootstrapping Hour. Today we're going to be talking about Keystone and how it works with all of OpenStack, how some of the flows work with the other components in OpenStack, things you got to be thinking about when you're using Keystone or building something that works with Keystone. So let's start with, we'll introduce our other host for today, and then we'll introduce our guests. Dan Smith. Say hi, Dan.
Hi, Dan.
One of our regular hosts helping out here today. Steve Martinelli, who's one of our guests today presenting. And David Stanek is our other guest here presenting. So with that, I'm going to turn over the floor to Steve and Dan. Why don't you guys do some introductions yourself, and then we'll start going through the slides.
Sure. So, a little about me. I'm a software developer at IBM. Keystone Core. Been involved in Keystone since about the Grizzly release around that time frame. I think that's about it. Stanek.
David Stanek. I'm a software engineer at Rackspace. I work on Keystone and Keystone Core. I've been in the OpenStack community only for about a year or so not very long. Doing Python for about 14 years.
Nice.
Let Dan go to the next slide. So the point of this bootstrapping session was actually to talk about the different authentication flows in Keystone. And if anything's not covered here today, you can blame Morgan Veenberg for bailing and subbing in myself and Stanek for this at the very last minute. So I figured we should actually kind of cover what exactly the identity API is and the different use cases it has. So again, if anyone on the Hangout has a point to make, just jump in there. Want more of a discussion format. So the identity API, for the most part, for users, the main thing that they all want to do is get a token and get the service catalog. The token they can then send off to other projects or resources and actually use them. The service catalog contains all the URLs for all the services that they need. And this is all done by doing a post request to, well, in V3, it's now /V3 auth tokens. Dave, do you want to talk about the admin use case?
Sure. So, whoops. So you want me to go through the different definitions here first?
Yeah,
Talk
sure.
a little bit about. So effectively, Keystone manages users and groups, right? Just like any other system that you would log into, and it divides users up into domains and then domains up into projects. And then effectively, you're going into Keystone to create roles for these users to tell them what they're allowed to do and which of these projects that they have access to. And then effectively, Keystone manages that catalog for everything else. Right? If you want to use create VMs in Nova, there's going to be a URL in there that Keystone has to tell you which URL to go to. And all these things are basically managed through Keystone. And then we have a higher level concept of admin, who is the person basically taking care of these actions, right? They're making the users and groups, creating the roles, setting up the basic structure for the users when they go in to actually use the system.
Yeah, so basically the admin's going to create all the stuff in there so that the users and the service accounts can actually use it. And the services are actually on the next slide. And that's basically any OpenStack project, so Nova or something like that, who actually needs the token, and they must validate it using the auth token middleware, which we'll get into later. And then alternatively, I guess for the heat use case, one of the main services is that they want to get a trust and impersonate a user. But that's basically the use cases for as a service. So all of that together is the identity API. So now we're actually going to go ahead and talk about what Keystone is. because a lot of people actually interchange these two, which kind of drives us a little nutty because they're not the same. So one of the biggest problems I put this out there on the Etherpad, and if you have any questions, please add them to the Etherpad. But one of the biggest questions we had asked was, how do we upgrade Keystone from version 2 to version 3? And it's like, well, it's not really something you can do because there's no version 2 or 3 of Keystone. It's the Identity API version 2 and Identity API version 3. And Keystone supports both. So in V2, there was no concept of domains, and V3 now there is, and there's concept of groups and a whole lot of other stuff. And it really started off in Grizzly, V3 support. So yeah, Keystone is just one implementation of the Identity API, and it supports both V2 and V3. Anyone can make their own implementation of the Identity API. There's a little bit more content there. One of the bigger changes was changing from tenants to projects, and using better support for RBAC through the policy.json file. I think those were the major differences. I don't know if you guys can think of another one.
I think the one that everybody talks about is the project and tenant switch.
Yeah, that really confused a lot of folks, and I'm not sure why. It was just basically changed from tenants to projects, going from V2 to V3, and it probably wasn't a better change. I don't know how much more helpful a project is than tenants. I don't know, maybe people just got mad because it screwed up their code. I don't know.
All the documentation all over the place is all wrong. Stuff that isn't controlled by OpenStack, blog posts, and all kinds of stuff.
Well, that was just more part of like a larger transition, right? Of like moving all of OpenStack to stop using the tenants terminology, but we're just not there yet. And Keystone went first because it kind of has to.
Yeah, and I don't know, what's the current support for using V3 for Nova? I think there's an active spec out there to actually start using it, I think. Right, John?
Okay, moving right along.
Dan could probably comment best on that.
No, I can't. I think the situation is probably embarrassing, as it's described. But.
Yeah, because I think part of it is like, a lot of the times Nova doesn't have to know because of what it does, and there are a few cases where it not being domain aware gets problematic, and those cases have not been addressed well yet.
Okay.
We're holding out for V4.
Yeah, V4 is going to be written all in Go, right, Stanek?
That's right. Work's already begun.
I guess we can start on the next slide.
Yeah, moving on.
All right, okay, tokens. Tokens are cool. Tokens are basically the keys to the kingdom. They're what you want. As a user, it's what you want to get at the end of your interaction with Keystone. That and the service catalog. And then you show your token to services. It determines what you can actually do. And there's 3 token formats, which I probably should have put on a slide before this, but that's okay. There's 3 token formats currently. There's UUID, PKI, and PKIZ. I guess we'll start off with UUID, and it actually looks better if we display the pros and cons of all of them at once, but it's okay. So a UUID token, I think that's the default now for Keystone, and it made a lot of other people happier because we swapped it out from PKI, which was the default before that. And the UUID tokens are they look a lot nicer. They're 32 characters long, provides a better user experience, doesn't cause any problems with a really, really large token in the header. However, the one big drawback is that you have to go back to Keystone for validation in there. You have to ask it, okay, is this token still valid? Yes, no, okay, then if it's not valid, go get a new one. If it is valid, then please proceed. And then we can compare it to the PKI token, which has its advantages over
Well,
the
effectively, the better user experience is kind of interesting because there's a lot of like small things that really make it hard when you're not using these tokens, you're using big tokens like links and URLs and just talking about it in chat or emails. But having the UUID, that small shared secret, effectively makes it easier to communicate.
Yeah, I mean, even doing like a curl request, you have to actually kind of encode the PKI token a little funny because there's slashes in there, there's plus sign, all sorts of things. So even doing a curl request actually becomes a little bit problematic when using a PKI token. So just to touch on the point that you were talking about, usability.
And so, and if I remember correctly, right, like UUID was the default, then PKI was default.
Right.
Now the UUID is the default again. Is that where we stand?
Yeah.
Yeah, so I think going back to V2, it was UUID, and then I think in around Grizzly or Havana, I want to say Havana, that PKI became the default, and now Grizzly's the new default as of Juno. Hope I got that right. So yeah, you can see on the PKI token, it looks like, and I shortened it a lot here, it's probably another like 3-4 lines. It's just this big ugly string. But the one pro is that you don't have to go back to Keystone for validation. It actually has the content in there. So you will see the expiry time within there as well. And you can see how the ID actually gets generated via the code snippet there. And what actually happens is you basically do this giant JSON dump of a token reference, this big dictionary. And if you have a lot of points in there and services in your service catalog, it's just going to grow. And then what happens is that dump of the JSON becomes very large. And then the end ID is actually, you do a sign of it using already set up certain key. And that's actually one of the other cons of it is it's a bit complex to set up. You have to set up your keys and your certificates to make sure that you already have this. You have it, that you can actually sign the things and use them. And like we talked about earlier, the ID length just caused a bunch of issues with different services because Swift has a header size limit and so does Horizon.
Well, Apache does. Anything running behind Apache, when it gets these like sometimes 9K tokens, Apache just won't let it through.
So this is just like a big JSON dump of the actual token and the whole service catalog, and then like base64 encoded or something.
Something to that effect. Yeah.
Why do we need to send the service catalog?
I think part of it was, and this is way before I got here, but I think part of it's an optimization so that you wouldn't have to go back to Keystone again to get a specific catalog for that user. Right? Because the idea is that you have everything you need to not go back to Keystone. So now you can validate on the in the middleware on the service itself, and you still have to go back to Keystone and get that catalog.
I guess I didn't realize the catalog would differ per user.
I think right now it mostly doesn't. I think there are use cases where they do want to limit catalog by user. I know that's one of the things that happens at Rackspace in their current implementation is that the catalog is different, and it actually governs somewhat what you can actually talk to.
It does seem a little nuts sending the whole.
Oh, absolutely.
Yeah.
That's the biggest part of the problem is that catalog, as it grows, it just completely blows out that token size.
So clearly no cloud users on 9600 baud modems, I guess.
I'm sure you could find someone somewhere, Dan.
I'm going to try, but I don't think it's going to work with this.
If they are, they're probably not using PKI.
Yeah. Okay.
And do you have like a sense of like how many more round trips than you incur on the UUID side? Like how substantial is the additional overhead if you're back on UUID versus this?
It depends on who you ask.
Every hit to a service would go back to Keystone. So you want to do something on Nova, Nova has to talk to Keystone. You want to do something on Glance, Glance would have to talk back to Keystone.
Okay.
So it's basically everything would have an extra hit.
Gotcha.
And
Well, I think they've started to deal with that somewhat through caching. I think that happens through middleware right now, where we can actually cache that in memcache, so we don't necessarily go back to Keystone.
Mm-hmm.
Right.
But I mean, there are some issues with revocation and other stuff.
Yeah. Well, there's huge. So how does PKI handle the revocation? I mean, you're just signing a JSON dict, basically, right? I mean, you can have Nova. You mean like if you revoke the Keystone certificate?
So it's actually easier for UID because you have to go back and it could check on the server side if the token's valid, right?
Right.
Here in PKI, we have lists of revoked tokens. So if the token has an expiration date and if it's still valid through that, you can actually look through a list of things that have expired or that have been revoked in that time frame.
Right. I thought you meant PKI makes that better, or makes that faster, but it doesn't, right? UUID
No, you still,
is...
PKI still has to have that list. So there's all kinds of complexities with how you deal with that, getting that list asynchronously and that kind of thing.
And when you get a token, is a token like how scoped is the functionality that you're allowed to do when you get a token? Is it like API wide? Is it like some subset of function?
it's all going to be governed by the roles that you have in the token, right?
Okay. So it's scoped to like the role. So it's just that like I am this user and I can do anything that this user can do.
It's not like you would get a token with less permissions than, like you would get a limited token versus an unlimited token. It's just all role-based, right?
Right. So yeah, it is role constrained, but it's role constrained on a resource. So it's either a project or a domain.
Okay. Yep.
So that's the scope token.
So if I'm Bob and I live in the accounting department project, I asked for a token, and so I can do any things that the Bob user could do in that project. But that token, if I try to take it to another project, it'd reject me.
Yep.
Okay, cool.
Or you might not even have roles on that project. But yeah, I know what you mean. Yeah, you're right.
Well, yeah, I just trying to understand, like, you know, when we talk about token, like, just what is the scope of, like, what are the permissions granted? Cool.
Then the last token format that we currently have is actually PKIZ, and this one's very similar. It just takes advantage of some compression and shrinks it down. Not much different otherwise. It got around, I think, the horizon problem that existed with very large headers.
Mm-hmm.
But I think for Swift, I'm not sure right now, but but I think Swift probably still doesn't handle PKI tokens very elegantly.
Obviously, not to try to solve all of Keystone's problems on the air, but in Nova we have a couple of places where we pass some pretty large chunks of data over a header, and we just like split it into like header 1, header 2, header 3, header 4, and concatenate it on the other side. So
there's actually, so the problem here is Apache actually has a total block size for headers.
Sure. Well, I mean, they clearly need to put less stuff in the header, but I'm just saying.
Yeah, which actually, like, we ran into, like, on the EC2 compatibility stuff in Nova, because EC2 doesn't use Apache, they use something else. And there's actually, like, a set of requests which can't be fulfilled in Nova if you put it behind Apache because EC2 doesn't care. So, anyway, cool. So let's keep rolling.
And then I don't know if you wanted to touch on the problem with the actual storing all the token data on the SQL backend, or storing all the data. Stanek, do you think that's worth touching up on?
Whatever you guys think is
Yeah.
relevant to people.
I mean, that's one of the common complaints, I think, about storing all that. We store tons of token data, and we effectively, every time you make a token, we store a record, and the table just continues to grow and grow. I think we have a cleanup job that you can run asynchronously, but it's still a huge problem, especially for people that are, we want tokens to be fairly ephemeral. You can just go get one and use it and get one and use it. And in that kind of use case, if you have a large cloud, you're just making millions of records.
Mm-hmm.
And I mean, and you're sticking that into a MySQL database or some other backend store. It just causes all kinds of issues.
Yeah, and then essentially when you go to revoke, it's going to look through that table, and it's just going to slow down to a crawl. And it takes up, we saw some complaints from customers where it was taking up like 90% of the CPU process or something.
Oof.
And they just had to run that job to clean out purge all the old ones, and everything was good, but it's still kind of silly. And we actually have a new spec that's being proposed for Kilo that's actually called the Authenticated Encryption Tokens.
Yeah.
Proposed by one of the cores, and it's essentially kind of this. Stanek, do you know more about it? Are you working with Lance on it?
Not really. I mean, I know it's kind of like a hybrid of PKI and UUID in that it's shorter and much more manageable, but it has enough information encoded into it so you can get the data out of Keystone without actually storing a full token record.
Yeah, and it's supposed to eliminate the entire bloat of the token database. So really hoping that one takes off.
Yeah, so I mean, like you'd still have the UUID problems of going to get the catalog separately. You'd have to, still hit Keystone for a lot of things, but you wouldn't have to store records in that token table anymore. So that solves a big problem.
Is there so the data that I'm looking at here, like that's like in these tokens, is there the reason you guys put in an SQL database is to provide some persistence should things like crash and you have to restore, right, or like come back up. Like, is there a reason that like in memory is no good? Is it like a sharding consistency problem? Like, what are the reasons that this stuff does get stored, or the technical trade-offs?
Well, so like in memory is a good question because there's a backend for tokens for memcache, but the problem that people have, and there's a bug in Keystone for it, is that different kinds of memory stores handle the data in different ways. Like memcache evicts your stuff out when it gets full, and so tokens just randomly get removed. And the way you normally deploy memcache, if you deploy in a fairly big ring, you can assume you can power down one and bring it back up, and everything works as it did before. It's not meant to be persistent storage. So there's a lot of issues there with customers that they wouldn't understand what's happening.
Because a cache has different different ways that it functions than an in-memory database. So all the caching semantics of, oh, you're kind of old, we're going to get rid of you, like totally break this. Yeah. Okay,
yeah, I mean, you could use an
total sense.
If you wanted to fire up a Redis backend and write the backend code to do that, you could do something like that.
Yep.
I don't think anybody has yet, but it's possible.
Cool.
All right. Otherwise, I think we haven't talked about this slide yet. So this is basically your typical kind of request to the /auth/tokens. And for the most part, it's broken up into two distinct parts. One is identity, the other one is scope. And the identity portion describes the user, his name, password, and the domain that he exists on. And then the scope portion represents the project that he wants to work on. So taking Sean's example, it would be Bob would be the name of the user, and then accounting would be the project name. For methods, you can also actually specify a token in there as well. So you can kind of get a token from a token, which is essentially kind of refreshing it, but not really. Getting a new one. And then also for the scope, you can actually, and this is a issue I think folks, for the most part, get this now, but when we initially proposed V3 in Grizzly or Havana, around that time frame, people had a lot of misconceptions around domain and project and domain name, project name, and those kind of pairings. Essentially, since domains are a collection of users, groups, and projects, you can't, if you're specifying a name, you also have to specify the domain name that it belongs to. You can have Bob at the domain company X, and then Bob at the domain company Y. So if you're specifying just the name, it's not enough. You have to also specify the domain name or ID. And the same goes for projects.
Is there so I know this is actually something that came up in one set of the Nova patches. I don't remember where we landed, but is there like a canonical representation that Keystone is using for that as a pairing? Like there were times where we wanted a config value that was like domain and name in a canonical way that so that we could specify for the v3 case something unique versus specifying like a UUID, which is way less fun.
I haven't heard anything about that. Maybe that was earlier on in the discussions.
Okay, we can take it offline later. It was just a thing that this how to be unique actually is interesting here, and like how do we make sure that we do this right when we try to consume it. Cool.
And then if we flip to the next slide, you'll actually see the response, which is your typical token. This is all the entire body of the token, all that stuff that gets signed in a PKI token. So as Static was saying, it dictates the methods that was used to obtain the token, the roles that you have on that project, which is 2 fields down, and the service catalog, which I shortened, and the user value in there. User value, I think, is probably more just for auditing purposes. And the response actually comes in the header as well. This response that you see here would come in the body, and then the header X subject token would actually come the response with the token ID in there.
Mm-hmm.
And you can see there's a lot of information there, somewhat duplicated. And since it's JSON, it's also fairly big and verbose.
Mm-hmm.
Yeah, I think at one point we had some ideas to optimize this and just maybe put IDs in there.
I don't know if it actually grew legs or anything. But yeah, there's talk of that.
So in the normal case, so with PKI, I was just looking at the expires at. So with PKI, you were doing expiry calculation locally. Is that correct? So like a service would like do the I was just wondering like how good you have to make sure all your clocks are to make sure that you know, a service doesn't like let things go on forever or whatever if you're doing local expiration.
Because there's no, well, there is issue at, right? So you can at least, if your clock is way off in the future, it should honor the issue at and not accept it in the first place, right? So that kind of gives you at least a window of exposure.
Oh, I suppose it's true. Yep.
Good observation. Yeah, there's been issues where even trying to think of the customer issue that we had where the clocks on one of their machines was off and they weren't able to authenticate at all.
That would be the issue that thing, right?
Yeah. That's awesome.
Keep your clock.
That's exactly what it's for.
Yeah, no, that's good. That's really good.
Yeah, it's all evaluated using, I think it's all based off UTC and not your local time. So,
well, the Z would indicate that.
Right.
Yeah, UTC encodes. Yep, which is good. Cool. And but in the UUID case, like you're constantly, whenever you evaluate whether or not a token is good, you're going back to the Keystone server. So in some ways, you're like more protected, right? Because it's going to tell you whether or not that's valid.
In that case, you have more than just time based, right? You have like I don't feel like validating this right now, right?
Right.
It only matters for the PKI case, really.
Okay. Cool.
The next slide's just a pretty simple depiction of your typical interaction. So the user would go to Keystone. His record would be in the SQL database or LDAP or something else. Provides his username and password, and then he should have a role on a project it's just basically a depiction, gets a token back and can actually use those tokens at other services. Just a very basic depiction to kind of sum it all up. And we have different auth plugins, so there's not just password. I mentioned that earlier. There's ones for OAuth, and there's ones for token and Kerberos and a few other ones. And then there's the auth controller code, which I don't really want to go into at the moment because I think it's kind of ugly. Someone should really refactor that, who's not me. Well, I think that's about it. I think we've done a bit too much on tokens, so let's keep going. Hey, identity backends. They're more fun. So Stanek, do you want to do the SQL one?
Yeah, so I mean, most things in Keystone are very pluggable. Identity backends we provide out of the box, an SQL one, LDAP one. The SQL one is really simple. It just uses SQL Alchemy to manage the actual database. You know, all the users, the groups, all that stuff are actually inside of whatever SQL database you have set up, MySQL, Postgres, or whatever. All the details on how to connect to it and how to deal with where it is on the network, they're all managed through the config file, which is pretty simple. It allows Keystone, and this is kind of something that we've been talking about getting away from a little bit, but it allows Keystone to act as kind of the identity provider itself. So all the user's credentials and the information about the user, Keystone would be the canonical source of that, as opposed to using like a corporate LDAP server or some other data store. Keystone actually owns that data. The pros are it's super easy to set up. Like out of the box, you just run the init command and it just works. So setting up like a dev stack or like a test cloud or something is just trivial to do, as opposed to like all of the setting up Active Directory or some LDAP server or some other external entity. And the cons, it should not be an identity provider. Right? Keystone really should be the central point and API, and just like OpenStack services, the API is on top of something else. And right now we just have that as an internal identity provider because it makes it easier to start up. We don't have really any good password support, right? You can put a password in there. We don't check that it's long enough. We don't make you reset it periodically. We don't check that it's one of the known bad passwords or must contain alphanumerics. So just whatever you want to put in there, you put in there, which is bad, but we don't really want people to use this in production. And then it kind of flies in the face of what people currently do, right? Most people, if you're in a corporation, you have an LDAP server or an Active Directory server that you currently store users in, or some other corporate store. And so instead of having another place where that information is, we should use that canonical data store. And then, going along with that, it just has another username and password for people to remember. So not only are you logging into your corporate network, you have to manage this other OpenStack thing when you want to use cloud services. And for customers, and business users, it's kind of a pain.
Good recap.
It's pretty simple.
Then the LDAP backend is actually pretty neat. So it should be accessing. So if you actually set up Keystone to use LDAP, it should use it just like any other application, like your email, like your corporate email or any other web application or system login. So basically, I think most, although we do provide support for more than users and groups, I think most people are just going to store users and groups in their LDAP. We do provide support for actually, I think, roles and projects as well. But I think for the most part, folks are going to manage the assignment authorization portion using SQL because there's not that many of them, and they're really more Keystone concepts than identity concepts.
And that's kind of an important point too, is that there's different portions of Keystone that have different backends, like the identity portion with users and groups and stuff, and then assignments have their own set of backends you could potentially use. So you can mix and match how that works.
So just so I get my head wrapped around this right, so if you're using an LDAP backend, which is considered the common case, then then basically all the user group and authentication, that's just like passed through the LDAP, but there's still got to be so like your cloud administrator is still going to have to create projects on through Keystone admin interface and assign users into that.
Right.
Like which part of things is going to be in a different store in Keystone that's not LDAP or expected in the common case?
Right. So there's two main parts, right? As Nick said, there's the identity backend, which can be LDAP, and then there's the assignment backend, which can be SQL.
Okay.
It can also be LDAP.
It can also be LDAP.
More, but most people will have it as SQL.
Yep.
And so for that one there, the administrator would typically just set up the LDAP stuff to be identity. Set up the identity stuff to be LDAP, and then set up the assignment stuff to be SQL, and he would create his roles and his projects in the SQL database.
But
and then, go ahead.
Is that where Keystone stores like its material as well? Like when it generates a token, it's got to store it somewhere so it can validate it later, right?
Right. That's another backend.
Oh, okay.
Each main part of Keystone is like a separate subsystem, right? Identity, tokens, assignment, and each one of those could have its own back-end store.
Okay.
Everything's overly configurable by default.
I didn't realize there was more than two, I guess. So.
Yeah.
Oh, there's a few. But yeah, the assignment one typically has projects, domains, and roles, because those are OpenStack concepts. We want to group them together. And it's up to the administrator to map users and groups to projects. So you don't have to do users one by one. You can do an entire group.
Mm-hmm.
So that makes things a little bit easier.
So you do like an OU like group, like everyone in this group gets put in this project, and it would do like a import or something. Or I guess would it do an import of the users into the SQL backend, or would it save like the group reference so it would search and reference by group later if that group changed in LDAP?
Well, there's a separate role assignment database which actually keeps track of all the assignments that are currently kind of paired up.
Okay.
There's like a target, which is a user or a group, and a resource, which is a project or a domain. And like a role ties them together. And the role assignment is the three of them all put together.
Okay. So the second thing, you assign like an LDAP group to a project, and then someone else is doing group management on that, and that would automatically like transfer over. Not transfer over, but or maybe I've confused everything even worse. That's fine. Let's keep moving.
It's one of the things that I don't think either one of us has actually worked on a whole lot.
Okay, no problem.
Yeah, for anything LDAP related, bug Nathan Kinder.
Okay. Cool.
Or Adam, he's good too. In hindsight, this slide seems kind of pointless.
Okay, we can keep jumping.
Yeah, it basically describes all the properties that you would want that you can configure for your LDAP. So basically, the users have to have an ID, a name, description, and same thing for groups. As you said, you have to use the distinguished name. Hold on a sec. So the name would be some sort of OU.
Mm-hmm.
And then, or the common name. You could probably use, probably the common name is the one that you want for the name and the ID. And then, every time a user actually connects to LDAP, I believe we don't even need to look up their password hash, because we would just forward that authentication request to the LDAP. So there's no need. So when you're configuring your LDAP, there's no need to actually store any, this is the user that I want to access the LDAP. You can do an anonymous bind.
Mm-hmm.
And actually the the link to GitHub over there, that's actually one of the methods I always end up putting the breakpoints at when I'm configuring an LDAP. Because in the end, everything's going to go through that method. It's the LDAP search function.
Mm-hmm.
And yeah, it just uses a Python library for LDAP communication, and you can, and alternatively, you can actually use several command line tools in Ubuntu to do comparable commands to search and filter.
Mm-hmm.
Anyway, it was just cool tinkering around with our internal LDAP, which you will see in the next slide.
Cool.
So for this one here, I actually ended up playing around with this a few weeks ago, semi in preparation for this, but not really. It's kind of on my own. And I was actually able to configure our own backend, configure our Keystone backend to talk to our internal LDAP. So that was kind of cool because most of the time, whenever I'm playing around with Keystone, I end up spinning up DevStack and using the SQL database, and it's always admin or admin OpenStack, blah blah blah. But this time here, I was actually able to, use the admin token, give myself a role on a project, and actually authenticate using my corporate email and password into LDAP. And if I did a user list and parsed it and passed in a group parameter, it actually told me all the users that were in the group. And the same thing happened for to find all the groups that I was a part of.
Mm-hmm.
Just listed them all there. So that was actually pretty cool to see it firsthand. One of the limitations of this is obviously you can't do a user list or a group list because it's just gigantic.
Mm-hmm.
It would just time out after a few minutes.
Once you've connected this, it's sort of like dynamically you get the entirety of the LDAP catalog on the back end. Like you don't have to admin in like this user can do a thing. Like they're all just sort of in some default domain to begin with.
Yeah, you're kind of getting it. When it connects to the LDAP, it actually does an anonymous bind, and then using your username and password that you've sent it into, it uses those credentials to authenticate with LDAP kind of underneath the covers,
Mm-hmm.
and then it'll try and, if you try and do a user list, it'll try and get everything. If you do a user list with a group parameter, it'll try and filter it to those groups.
Yep.
And just like SQL, that's a query to LDAP, and when there's tons of data, you start having issues.
Yep. And I know the LDAP that Steve's hitting, and there's a ton of data in that.
Oh yeah. It's all like 400,000 users or something.
Yeah, it's even more than that. It's limited to 100,000 per poll.
Oh, I didn't know that. Cool. Still timed out. And well, one of the cool features, if you flip to the next slide, that we were working on that Henry Nash was working on for Juno, was to kind of do support for multiple identity backends. So, kind of give you the overall picture. These are just two of the backends, the identity and assignment. And the assignment one would still use SQL, as we discussed earlier. But identity, now you can use multiple backends. So, you can plug into the corporate LDAP to manage all the users, but all the service accounts can now be in SQL as well, which is basically something that people always wanted from the beginning. Because the problem with setting just the LDAP is, say you have a service account admin or Nova or something, the guys in control of LDAP aren't going to allow you to create users, just because you want another one in there. They're going to be very, restrictive about that. So this is something actually a lot of customers wanted from the beginning.
So just to be clear for people that may not be understand all those use cases there. So this is the service domain is this, we're talking now, correct me if I'm wrong, about the set of users that like different services in OpenStack would use to call each other to do administrative actions.
Correct. So like Heat or Nova or the admin account, stuff like that.
Yep. And yeah, it makes total sense. Like, you know, yeah, you're not going to have access to corporate LDAP to go modify those things, but having it be able to be per domain split and then an SQL backend, that's cool.
Yeah, because everything pre-Juno was, all right, you have one identity backend and that's it,
Mm-hmm.
which wasn't enough for most people.
What, 640K is enough for everyone.
You say that now.
Then, Stanek, your favorite topic, the Keystone middleware.
Yeah, so if you go to the next, this slide, basically there's a really simple diagram showing some customer service interactions. This really shows a more complicated case where customer is talking to a service and that service talks to another service. So say the customer talks to Nova, and then Nova has to talk to Glance on their behalf to do something. But the idea is that you're flowing through. The first step is a customer gets a token from Keystone like we were talking about earlier, and then the customer gets that catalog and knows now it needs to talk to a service like Nova, and it uses that URL or uses the client to go talk to the service. And this is where the whole token evaluation stuff that we talked about earlier comes in. We actually have middleware that you run on each service, and that middleware basically intercepts the token before it goes into the service code and decides whether or not to let it through. And at that point, it looks at the token type, whether it's UUID, and then it makes the call to Keystone, or it looks at the expirations and other data inside of the PKI token to figure out if it's going to let you through. And if it's not, you get bounced with an authorization error. And if it does, we put some stuff in the context so that the service that gets called has all the information that we got from Keystone at that point. And then effectively, the service can then go take that same token and reuse that to talk to another service behind the scenes for the user. So like the simple case of Nova talking to Glance to do something. And then that operation happens on every single service. So Glance would get the token, the middleware would look at it first, decide whether or not to let it through, based on expiration, roles, all the other data that's in the token. And then, if Glance decided to do something else with the token, the same process would keep happening until the user gets whatever action they requested completed.
And this includes like revocation lists and all of that too, right?
Yeah, the middleware should take care of all the things related to making sure the token, by the time the service is called, the token should be validated.
Okay, yeah, so then this just like massively simplifies writing the services because you put this in front of you, and if you get to your code, it's okay to move forward.
Yep. And this is where it gets really interesting because there's a lot of complexities that are hidden by the middleware that you don't have to deal with. So it makes writing Nova a little bit easier. You don't have to take care of any of that authorization stuff, revocation list stuff, dealing with looking through roles or know anything about that stuff. You just get the data back once it's complete.
Cool.
So this is also one of the reasons why. So there's always this: how long should we have our tokens expire? Right? Like you want them short so that they expire quickly, so the users have to go fetch them again, so you know they're good. Because effectively, a token's like a shared secret. Anyone who has it acts as that user for anything they want, right? So because of this, depending on what services you're talking to, you have to have the token lifetime longer than the expected operation you're going to have. So if something is going to use that token, and it's going to take some amount of time, or it's an asynchronous job, if that expires in between, you could run into issues. And especially if it's asynchronous, the user might not even know that there was an issue for a day or two until their, admin comes knocking on the door because something broke.
Yeah, that became a mailing that started not that long ago because we definitely run into these, so there's like certain like volumes operations, like some of the backup stuff that can take a long time all by its own, and then just Tempest in its own client for performance reasons doesn't generate. It generates a set of tokens early on, and then it knows they're good for a long time, and so it continues to use them. And if certain things take a really long time, or like if in aggregate tests take too long, it'll actually like hit, oh wait, this token's no good anymore. So.
Yeah, that's disheartening from a user standpoint to get those kind of messages when you just click the button on Horizon to do something.
Right. Yeah. Is there any like? I thought you said somewhere earlier that there was like a way to use a token to get another token. Is there a way like that retry could be implemented here using that?
I think you'd have to do it before that expiration, so you'd have to.
Try to know you're getting close.
You would have to know to do that.
Yep.
You could do that though.
Cool. Interesting.
Steve, does when you get the new token, does it have a new expiration based on the default lifetime, or does it take your old one?
No, it should just be a complete refresh.
Okay.
Yeah, it should have a new expiration time.
Yeah, the Keystone middleware is always something that like was like weird and mysterious to me. So it's nice to kind of see some of this displayed here.
I mean, the code is a little complicated, but it is pretty simple in concept, right? It's nice. The design is pretty nice and how it works. Just if you look at the code, there's a lot of stuff that it has to take into account, so it's kind of messy.
Mm-hmm. And then today, so in the dependency chain of the world, we end up dragging in Keystone middleware with the Keystone client kind of everywhere, like because most of the projects don't depend on Keystone middleware directly, right? But it's like it's sort of embedded with the client.
Well,
today.
It was. Yeah.
Okay, it's a separate package now.
Right.
But it's still being kind of dragged in by the client as like a second dependency, right? Like the projects don't depend on it directly, or has that changed?
I don't know if middleware depends on client or vice versa.
Okay. That's a minor point. I'm just kind of curious how it all glues together.
Middleware depends on client.
Okay.
Yeah, that's correct. Middleware does depend on client. So if you're pulling in middleware, then you're probably pulling in client as well.
Okay. Cool.
But I think everyone was really happy when we actually split out middleware from client, just because architecturally it made no sense to have it existing in the same package.
Yep.
Just convenience, because everybody already had client, so it's an easy way to get it everywhere.
Yeah.
Cool. Well, let's keep moving because we're getting close to the top of the hour, but we've just got a couple more things to touch.
Yeah. So this part here, one of the things we've been working on for the last 2 releases has been better support for federated identity. Basically, the use case is, you don't have access to the LDAP, and you still want to authenticate with Keystone. You should be able to do that. And there's cases where a company can actually have like their own, they already have their own single sign-on already set up, or as said there's inaccessible LDAP, but the user should still be allowed to use Keystone. So maybe there's a few different reasons for this, but essentially a lot of folks already have a single sign-on mechanism, and they should be able to use it. So I think as of not today, but a few weeks ago, we added in OpenID Connect support, but since Icehouse, we actually had support for SAML too. So basically it means if you actually flip to the next slide, it'll be hopefully a little bit more clear. So the way it kind of all works is we really want to run Keystone under Apache or some sort of HTTPD service. And then from there, we can actually leverage a lot of Apache libraries that handle all this handshaking that's very complex to code and cumbersome. So we can inject these libraries into Apache, and you set up a few config options. It'll actually redirect the requests accordingly. So the main use case, the main kind of flow is There's a user, he goes and tries to authenticate with Keystone on some protected URL, gets redirected to his SAML identity provider or OpenID identity provider, at which point they authenticate like they normally would. So you can, you can configure it to work with Google, or you can configure it to work with some sort of SAML IDP that's backed by our LDAP. So I was playing around with it with our internal tools, and it was working out fine. So once they've authenticated with the identity provider, they then get redirected. The assertion, the actual claims, all the stuff that's actually representing the user actually gets pushed back to Keystone, and from there we go and we do a mapping, which the Keystone administrator sets up. So, based on, all right, if Bob authenticates safely with this IDP, and the username and the SAML assertion says, Bob and the group member is accounting, you should go into the accounting group. If you actually flip to the next slide, you'll actually see how the mapping is actually done. So in this case, it's some user and the group member is OS admins, and all these properties on the left-hand side are actually coming from an identity provider, so Google or your LDAP backend or something. And then once you hit the mapping engine, you have a set of rules that translate. It's a very long set of rules. You can have a short set of rules, you can have a long set of rules. Essentially, you want it to actually translate to a Keystone concept. You want OS admins, all the guys in OS admins should be part of group ID ABC123. And as the administrator, you should be able to list groups, find the ID, and slap it in there. And then every time they authenticate, they're going to be part of that group ID. So, yeah, I mean, it's pretty cool. CERN's using it now, and they have some really cool stuff in the works.
What is their so they are using like an OpenID or OAuth backend? Like, what is their sort of intermediary source? Or is it the same stuff?
All their identities are actually stored in ADFS.
Okay.
It's an ADFS server, and yeah, that's it's the Microsoft ADFS, and then that's their identity provider. So then when they go there, and the assertion that the ADFS actually shoots off is very similar to a SAML assertion. So we have to actually make a few changes to the code to take care of that.
Mm-hmm.
So this is kind of like the LDAP backend, but done the right way and loosely coupled instead of us doing all the work.
Yep. Well, that's pretty neat.
Then the Apache modules actually end up doing a good chunk of the work, which people are kind of happy about, not happy about, because they really, really like Eventlet for some reason, because it's easy to spin up and it's fun.
How much of the work that Apache does is specific to it being Apache, or could be done on another open source HTTP server?
Good question.
I think it could be done other places. Just the modules exist for Apache already.
Okay.
So it's very easy to just reuse all that existing code and infrastructure.
Yeah, I was just wondering because there's a lot of people I think I've seen on some of like the TLS proxy stuff that are really into Nginx. I wasn't sure how much this leverages stuff which is Apache exclusive, or that would be just as easy over there, or whatnot.
I think from a Keystone perspective, it could be agnostic. It's just that right now we use or recommend mod shib because that's basically done for us.
Yep.
And if something exists on Nginx or Lighty or whatever other HTTP server you would use, I think it would work just fine. Or we can make it work and adapt.
Cool.
And then, I don't know if you want to wrap it up, or did you want to do the last slide?
Yeah, we can go a little long. So, I would say hit the last slide, and then we'll. We don't have questions yet in Etherpad. We'll call for any additional questions that people want to throw in there. But yeah, hit the last slide.
Sure. So, a lot of people have been using Keystone Client for a long time, but it's essentially two parts. It's a library and a command line kind of bundled together. And I think back in Grizzly, I think Dolph put his foot down and said we're not going to put any V3 functionality in for the command line portion of Keystone Client. We're still going to create the APIs, however, to use as a library, but any of the command line support should all be piped into OpenStack Client, which actually just was cut yesterday to have a 1.0.0 release. So
Nice.
yay. And we promise not to screw up anything. So yeah, it actually supports V2 and V3 of the identity API, and it actually supports quite a few Nova functions and Cinder and Plans functions, and even a few Swift functions. So pretty awesome. So go use it.
Yeah, and don't have to remember which random service you have to run the command line for to do things. Yay, OpenStack Client.
And yeah, that was the only support that we've had, because there was a while for, I think, an entire release where we just kept getting bugs and bugs more. And there's just, there's no V3 functionality in Keystone Client, no V3 functionality in Keystone Client. So we just kept marking them as won't fix. And we got a lot of bugs about that.
Cool. All right, so I'm looking at the Etherpad. I don't see any questions there at the moment. We still have a bunch of viewers online. I don't know, Dan, do you have any final parting questions? We are kind of at the top of the hour.
I do not.
Okay. Well,
I want to talk about Nova and Keystone V3.
I don't think Dan wants to talk about Nova and Keystone V3.
I do not.
All right. Well, Steve and David, thank you very much for coming to us today. This was great.
No problem.
And yeah, and I'm doubting that we'll have another one of these bootstrapping hours before the holidays. We need to work out kind of the schedule going forward, but holidays are coming up on us quickly. But we'll definitely see everyone back here in the new year.
Thanks for having us. It was a lot of fun.
Yes.
Yeah,
Thanks again. This is great. This is really great. And this will be up on YouTube in about 10 or 15 minutes once the encode finishes. So I'm going to sign off now. Thank you, everyone, and we'll see you in the future.
Thanks, John.